Let's go through LeetCode 1998 GCD sort of array. For this question, it gives us an integer array. And for any two number, if they have GCD greater than 1, then we can swap the number. We can swap those kind of number as many times as we can. And it asks after some times of swapping whether we can sort the array in non-decreasing order. Let's take a look at the example. For example, 7 and 21. They have GCD comma, that is comma greatest common divisor, that is 7. And also 21 and 3, the GCD is 3. So you will see that we can swap 7 and 21. And also we then swap 3 and 21. We get a 3, 7, 21. So it is the non-decreasing order. So it returns true. But the second question, you say that because we have 5, right? Second example, and 2, 6, 2, you can swap. But anyway, if we because the 5 cannot swap with the other 3, so the 5 will be greater than 2. So it will not have any way to put the 5 after 2, right? So it returns false. Intuitively, what I was thinking about is that we try to compare every two numbers, trying to see if they have GCD greater than 1, right? If they have, then put that into a set. So what we're thinking about is that if we have any two numbers, we try to put that into a set. That means for some of the numbers, for example, 10, 5, 8, 3, 10, 5, and 15, right? They belong to one group, right? And 9, 3, they belong to one group, right? So there are two sets, right? So what we're thinking about is that we use some kind of, as long as there are some kind of two number can have GCD greater than 1, we have put that into one set. So what we're thinking about is that we use a data structure called unified, right? So we create a unified and trying to check for each element if they belong to the same set. If they belong to the same set, we can sort. For example, sort this kind of set, right? So and also 3, 9, they belong to the same set, so we can sort this. So we can do sort for each set. For example, we have A1, A2, A3. They belong to one set, right? If we sort that in ascending order. And then we have, for example, B1, B2, B3, B4, B5, right? If this belong to one set, right, we sort B in ascending order. After we sort, right, we have another array, or we compare whether the whole array is in non-decreasing order. So there is one thing is that we'll see the nums length is in 3 multiplied 10 to the power 4th, right? So if in this case, if we do the GCD pairs by pairs, it will be for example, it is n, right? It will be n squared, or O n squared will be out of time, right? So what we think about is that possibly we can have a map for every number, right? We write as the prime multiplications. For example, we have prime 1, prime 2, and prime 3, right? Multiple by. So we can have a map. The key, for example, will be prime 1. It will have a list, right? They will have num1, right? And also, if num2 have prime 1, A, prime 3, B, right? So this will have num3, num2, right? And the prime map, the key prime 2 will have also have num1, right? And also P3 it will have num1, num2, right? So what we do is that we union, we write a number as multiplications of those kind of prime products, right? And we have a key as a prime number. And then what we do is that after we compose this map, we do union find for the values, right? So in this case, we for every number we do the prime and compose the map, and for the map values we do the union find. In this case, we instead of n squared, right? And we have every number, it will be constant to be the prime products. And also for the values, right? This is ON, right? So in this case, it will the time complexity will be better. So let's begin to write code for this. So we know we need to compose the map, right? So map, the key will be the prime, right? And also what, let's put the index so that we can handle the numbers because for example, if we set the numbers, this in one set, right? So if we have 0, 3, 4, that is the index, right? We can check the numbers in it because we want to sort these numbers. And for these numbers, we are put that in back to this kind of index, right? So let's put the index as list of index as a map, right? As a value. So we call prime map equals new map. So key, that's right. This key, right? Key will be the prime number, right? Value list of integer will be list of index, right? So let's write for int I. Let's have int I equals nums, total nums. Okay. For int I equals 0, I smaller than n, I plus plus. Let's have build a map. Okay. So we'll have let's have an index. Okay. So we'll have nums I, right? Nums I. And also we need to have the index, right? Prime map. Okay. So let's write this one. Have it void build map. Okay. So we need to have this number, right? And also we need to have index. And also we have this parameter. We need to compose this map, right? So what we do is we know we need to do this, right? For int I equals 2, I smaller equal to num, I plus plus, let's say while num greater than 0, and num mod by I. equals to 0, right? So you will have num divided by I, right? And also we'll have let's put this one as set, right? Otherwise, every time we'll put that multiple indexes in the one key, right? So we'll say map compute if absent I a goes to new hash set. What we need is to add the index, right? So we write any number into product docs of the primes, so that we put this kind of things into the map. Okay. Now let's write the union find class. Okay, class union find. Okay. So what we know is that we need to have a father, and a public as a house constructor union find int n. So we know father equals new int n. Okay, we initialize for int I equals 0, I smaller than n, I plus plus, we have father I equals I, right? And we need to have public void union int A int B, right? So let's say int FA equals find A, int FA equals find B, right? So let's say if FA dot A doesn't equal to FA dot B, we'll have further FA A equals further FA dot B, right? A, B. So this is a union, and also we need to have find, right? Public in find int x, right? So I say if father x equals x, we just return x, right? Then we'll have father x equals find father x, right? Doing like this, we have the recursively have the test compaction, return father x. So this is the union find class, okay? And what we do is that we need to firstly is that when you union find UF equals new union find the extra n, right? So what we do is that for the map case, we need to union it, right? So we'll say for set integer set and prime dot values, right? Values. For the set, it does not have iterator. Let's convert this one into list. List equals new array list set, right? So what we do is that we union from the index 1 to everyone unions to the union index 0, right? For int I equals 0, I smaller than list dot size I plus plus will have you have union list get 0 and the list get I, right? So doing like this, we have we have a union union those kind of numbers which have GCD greater the one, right? So we in the set that is the index, right? Now what we need to do is that we have another map, right? The key will be the parent um, for every set, the top parent index, and also the value we are also using integer, list of integer, will be other indexes, right? Let's call this called set map, okay? Means they belong to one set, right? New hash map. And what we do is that we are check int I equals to 0, I smaller than n, I plus plus, right? So we'll find every parent, right? Parent index equals in find AI, right? So let's say set map compute if I sent parent A goes to new array list, right? Right. So this is we in this case the entry counts will be how many sets, right? And we compose another array called array equals new int, and okay. So we need to sort the values, right? And but in our list set these kind of values that is index, right? So what we do is that for int list integer call index list, right? In set map dot values, we'll have let's have the number lister, okay? List integer num list equals to new array list, right? So what we do is that for every number array index in index list, we'll have num list add is num's index, right? And we sort these two, right? Sort collections, sort index list, and also we'll have collections sort num list. Okay? So now let's put so we'll see for every subset, right? The index is sorted, the value is sorted, so that we just put these values to this array, right? So what we do is that we'll say for int I put 0, I smaller than index list dot size I plus plus. So we'll say array index with it equals num list it, right? So we sort every subset, right? And now let's compare the whole this kind of array changes with they are in order, right? So what we do is that for int I equals 1, I smaller than and I plus plus will say if array I is smaller than array I minus 1, so we return false. Otherwise, in the end, we return true, right? So this will be the code.